WPR number 2. Again, we have an absolute value inequality here, and I'd like to separate this into two inequalities as we've been doing with the other absolute value inequalities. The problem today with this example is that we have something in front of or in addition to the absolute value on the left-hand side of this inequality, and it can't be there. We can't split this into two inequalities until we only have the absolute value and what's inside of the absolute value on the left-hand side. So I'm going to go ahead and start this problem by dividing both sides by -3. Now, remember that when you divide an inequality by -3, you must reverse the order of the inequality. And so I end up with the absolute value of 6 minus x is greater than 5. Now I can split this into my two inequalities, which results in 6 minus x is greater than 5. Also, 6 minus x is less than -5. I will subtract 6 from both sides. And after I subtract 6 from both sides, I'll be left with -x is greater than -1. I'll also have -x is less than -11. And again, in each of these, I need to divide by a -1 so that I'm left with just x on the left-hand side. But because I'm dividing by a negative, I need to reverse the order. So I'm left with x is less than 1, and I'm also left with x is greater than 11. And we have to ask ourselves, can you find a number that is less than 1 and greater than 11? And of course, the answer is no. There is no number that is less than 1 and greater than 11. So I will put the word or in between these, and I can't combine them into one inequality with x in the middle. This is an or. Of course, we knew that before we began the problem, because when we have this symbol, the greater than symbol, or the greater than or equal to symbol, we will have an or problem. And when it's an or problem, the shading is away from the middle, and so I will have 1 and 11 on my number line. I will circle those values, and I will shade away. When adding and subtracting radicals, you can only combine them, that is, you can only add or subtract them if the radicands are the same. And in this example, our radicands are not the same. So it doesn't look like there's anything I can combine here, but there is a radical that I can simplify. Now, the first one cannot be, because I can't take the square root of 2 or b, but in the second term, I can rewrite 18 as 2 times 9, and I can write b cubed as b times b squared. And the idea when we have a variable with an exponent is that we pull off the variable to the power of 1, leaving the variable with an even exponent in the other term. So in this case, I have b1 and b squared. Also, the third term here cannot be simplified, so I'm left with 7ab square root of 6b. So I'm going to go ahead and rewrite the first term, but I'm going to continue to work on this second term. I can take the square root of 9, that's 3, and when that 3 comes out, it's multiplied by the 3 on the outside, so I get 9, and when the b squared comes out, it comes out as a b, so I'm left with a and a b, but the 2 and the b stay inside. Third term is staying the same, and so now I have a situation where I have like terms because I have an AB on the outside of each of them and a radical 2b. So I have 4 of these things called AB radical 2b minus 9 of these things called AB radical 2b, which leaves me with -5AB radical 2b plus the 7AB radical 6b. Now these look very similar. They both have an AB out front, but their radicands don't match. So they are not like terms. They can't be combined, and this is our answer. When working with the radical equation, we'd like to square the radical to get rid of the radical and expose the radicand. Unfortunately, in this problem, the radical's not by itself. So my first step is to clear out that other term, in other words, add 2 to both sides. Now I can square both sides. So the square root symbol is now gone. And many students tend to look at this and say, oh, if I square that, I get x squared plus 4. But be careful, because when you square it, you're multiplying it by itself, and you would do so using FOIL, which wouldn't give you x squared plus 4. Instead, it would give you x squared plus 2x plus 2x plus 4. And I have a quadratic, and what I'd like to do is get all the terms on the same side. I'm going to add these two x's together first to get 4x, and then I'll subtract the 3x over, so I'm left with 1x, and I'll subtract the 16 over, so I'm left with negative 12. So I have x squared plus x minus 12 equals 0, and when I factor, I'll get x plus 4, x minus 3, which looks like then I'll have the answers negative 4 and positive 3. But if we check these answers, let's check the 3. 3 times 3 is 9, plus 16 is 25. The square root of 25 is 5. 5 minus 2 is 3. X is 3, so I have 3 equals 3. This answer checks. That's an answer. But what about this negative 4? 3 times negative 4 is negative 12. Plus 16 is 4. The square root of 4 is 2. 2 minus 2 is 0. 0 equals negative 4? No, not so much. So the answer is 3. With a complex fraction, I'm trying to get rid of each of these denominators. So I have a denominator of 4, 4, 4, and 2x, which is made up of a 2 and an x. Now, if I multiply by 4, I'll get rid of that, and that, and that. And I'll also get rid of a 2, because a 2 would reduce to 1 when it's multiplied, when this term is multiplied by 4. So this would end up going away by just using a 4. But I also need an x, so it looks like I need to multiply every term by 4 and x. When I do so, I get some things to cancel here. These 4's cancel, these 4's cancel, these x's cancel. 2 goes into itself once and in a 4 twice. So again, that 2 is reduced to a 1, and that's our goal. Our goal is to reduce each of these denominators to a 1, and that happens here by using a 4. Those 4's also reduced. So now I'm left with x and x. When I multiply those, I would have x squared, and here I'm left with 1 times x. In the denominator, I'm left with 2 and x. So it looks like this would be the answer, but I should try to factor, and I can factor the numerator. It factors into x times x minus 1 over 2 plus x. It was a valiant try. We factored. Hopefully something, we were thinking hopefully something would cancel, but we don't have any like factors in the numerator or the denominator. In other words, if I had an x in the denominator that was being multiplied by something, I could reduce this x with that. This x is being added to the 2. Remember, adding is a bond that can't be broken. You can't break the bond of addition, only multiplication. So I cannot cancel or reduce those x's. This is the final answer. When solving a fractional equation, we can multiply through to eliminate the denominators. In this case, my denominators are x minus 3 and x minus 3. So I'm going to go ahead and multiply every term by x minus 3, including the 2.
Hi.
Hi.
How are you?
I'm good. I'm recording a lesson. It's okay. It's all right. So anyway, I'm going to go ahead and reduce. Whoops, that doesn't reduce. And I'm left with 4x equals 2x minus 6 plus 12. When I solve this, I would subtract 2x from both sides, and x would be equal to 3. Of course, when I check this answer in the problem, I would have 3 minus 3 in each of these positions, which would be 0. We cannot have 0 in the denominator. That means there is no solution to this problem. So we would say the answer is either the null set or the empty set. They both mean the same thing. In this example, I'm subtracting fractions. When you're adding or subtracting fractions, you have to have a common denominator. These denominators are not the same. I can't subtract these fractions. I need to make the denominators the same. One thing I'll do first is I will factor so that I can compare the factors of the denominators. I see now that the first denominator is missing the factor of y plus 5, so I'm going to go ahead and multiply the denominator of the first fraction by y plus 5 to make it a common denominator. But if I do that, then I would need to multiply the numerator by y plus 5 also. I'm also going to add the opposite, and when I do that, the result will be that I'll have a negative y minus 5. Now I have a common denominator, so for my answer I can write my common denominator and combine the numerator. I'll have 6y plus 30 minus y minus 5, which if I combine the terms in the numerator will give me 5y plus 25 over y plus 5 times y minus 5. Of course, I can factor the numerator and cancel the y plus 5s, leaving me with 5 over y minus 5.